We're now speaking with Dean Athens, who is president of Engine Alliance. Dean, thank you for letting me visit with you. Let's start off with the question that is perennial for many people observing Engine Alliance. Pratt and GE are fierce competitors in the narrow body market with, for example, LEAP and GTF. Can you talk to us a little bit about the potential clash of cultures within EA?
Okay. First, there really is no class of cultures that exist on the EA team. We've put up firewalls for antitrust concerns at both our companies, and we have a substantial dedicated Engine Alliance team. So we've got complete teams dedicated just to GP7000 and Engine Alliance for systems integration engineering, product support engineering, aftermarket, customer program management, and so we're able to focus on the business of the EA and the issues that we need to work on for the GP7000. And that, although those forces do exist at our parent companies, they don't penetrate the Engine Alliance, and it's really no issue at all. And even at the leadership level, the board members who make decisions for the Engine Alliance from both of those parent companies are very supportive of the Engine Alliance. And so there's a very good job of not letting that competition affect the Engine Alliance.
Okay, so the EA engine, the GP7200 or 7000, has done extraordinarily well on the 380, but it's still only on one program. What else is Engine Alliance looking at? Is in fact Engine Alliance looking at programs beyond the 380?
There's really nothing on the horizon. It's not that we would rule it out, Addison, but there's nothing on the horizon. And the GP7000 was conceived as a product specifically for very large aircraft, VLA. And I wasn't around during the very beginning of this concept, but the story I've been told is it actually came from the Boeing side. With the competition they had on the 747 with 3 engine makers wasn't functional. So they suggested that there be a partnership between GE Aviation and Pratt & Whitney for a very large aircraft to replace the 747 at Boeing. And because a very large aircraft like that isn't going to be a high volume product like a 737, there wasn't the volume to support 3 engine makers. 2 engine makers would be much more functional. It would be more consistent, a better match for a lower volume product like a VLA aircraft. And what happened eventually is there was no next generation product at the time for the 747, and Airbus developed the A380. So the Engine Alliance was a logical fit, and it works very well. And we see that although the A380 is a successful airplane, particularly at Emirates, it's a good fit for a partnership because it's not high volume. We're able to share the development cost, share some of the other aspects of running the program, and it allows us to do it at the Engine Alliance at a healthy business level. If you have 3 engine makers and they're all struggling, it hurts everyone. So.
All right, so you brought up Emirates. The natural question about Emirates is Tim Clark's thoughts about a 380neo. Any thoughts on that you could share in terms of what he's looking for?
Yeah, well, and I think it's pretty clear. I probably learned more about what Tim thinks and says through the press than I do firsthand. Although I do spend a lot of time in Dubai and talk to the leadership at Emirates. But he really is looking for a big leap in performance to support. He's got a very large fleet. And fuel is a big part of running an airline. To the extent he can make take a big chunk out of his fuel bill, he'll save Emirates a lot of money. So I think that's where he's coming from. If I was him, I'd be saying the same thing. They're buying a lot of aircraft. They're the world's biggest and growing wide-body airline. So he has the credibility and the weight to say something like that and have people take notice and respond to it.
So if we look down the road, I'm sure the GP engine has all kinds of PIPs and other terms that you guys use to describe improvements. Can you give us an idea of the path that, as you look forward, What are you doing to the
Yeah.
engine to keeping it current and number
Yeah.
one, so to speak?
Well, we always are, and we have a sustaining engineering budget and a sustaining engineering team. So we're always looking at things that we can do to make it better and more reliable. But those are incremental things, Addison. For anything substantial, we really need to take the lead from Airbus. I mean, it's the Airbus program. They need to set the vision, timing, scope, etc. for those things. So we're always going to be monitoring our fleet very, very closely and very carefully. We're always going to be pushing reliability and durability. So we're always going to be investing in things to bring the most value out of the architecture today, if you will. And that's one area where that we don't restrict our resources. I mean, if there's something that we find in the product that is not delivering the results that are expected, we automatically assign the resources and take care of those issues.
So the reason I'm asking that question is because of your briefing this morning. You were talking about how you're improving the fuel burn of the engine. Could you share a little bit of that?
Yeah, well, we've done a lot of work. So when you have a large engineering team and they're constantly doing work and analyzing things, they come across opportunities. So it's actually our principal engineer that we added to our team last year was aware of some of the new concepts and came to us and said, we have an opportunity. We have a system on the engine that we're not leveraging in the climb phase. And what that system does is it optimizes the clearance in the high pressure turbine. Now, we weren't using that system during climb, so we were leaving the clearances very open and not taking advantage of some performance capabilities. So it's a great concept. He said, listen, we can exercise our active clearance control system, reduce the clearances during the climb phase, which is up to 20 minutes, and burns quite a bit of fuel. We can realize the savings. And so we decided to do the work. We did we launched the program, we did some engineering work. We actually wrote the software to test that concept at several different levels and flew it on the aircraft in January of this year. And we're actually surprised at the results. One thing I didn't say during the conference this morning is when they got on the plane to test the software, the Airbus test pilot said, we won't be able to see this difference. It might be in the data and we'll have to analyze it statistically, but we won't be able to look at the engines and tell it's any different. Well, they flew the aircraft, they got up in the climb, they looked at their instruments and they went, holy cow, we can see the difference. Come up here and look at this. This engine with a special software has a much lower fuel flow rate. And the engine EGT is lower than the other three engines. This software really works.
What is the savings that you would estimate from that?
We're with 40 degrees reduced metal temperature during climb, and climb is the part of the A380 mission that puts the most stress on the engine. So even more so than takeoff. So by reducing the metal temperature 40 degrees during climb, we could extend time on wing 1 to 200 cycles. So you get some time on wing benefit. The fuel benefit, even though it's only 20 minutes and it's a half to a full % fuel flow, depending upon the D rate used during the climb phase, it still adds up to a substantial amount of money in fuel savings over, even just for one aircraft for 1 year, would be hundreds of thousands of dollars in fuel.
And the current customers are all going to be able to get that as an improvement package?
It will be part of a software program that we've already launched. This next software version for the GP engine will be introduced in mid-2015, and it will be rolled out to everyone. Not only will it have this, but it'll have all kinds of other benefits. Usually when we do a software roll, we get a long list. We'll actually consult the customers, consult with Boeing, and we'll get a consensus agreement on all the improvements that we're going to put in that software, and it's a very quick upgrade. It can be done on the flight deck. All engines can be upgraded very quickly, and so the entire fleet will get it, and they'll be able to upgrade their entire fleet in less than 6 months.
That's fantastic. Now, there's talk that your engine is 1% more fuel efficient than the competitor. What'll this improvement do? Does it make the delta greater, or are they catching up?
We have to and Airbus does the job of how we compare fuel burn. This absolutely will. Now the savings is in climb, but it's a significant savings. There will be, a total mission fuel savings as a result of this change. But when you dilute that 20 minutes over a 5-hour flight or a 7-hour flight or 9-hour flight or a 16-hour flight, it dilutes the overall benefit. And so Airbus may not recognize that formally. It's absolutely there, but there may be no formal recognition of it. But if we do enough of these little things, eventually you start to build up a fuel savings benefit. Airbus will fly 6, 10, 12 test flights with fuel flow meters on the aircraft, and if they validate a lower fuel burn, they will eventually officially recognize it. But that's a specific process that's under Airbus control. We're not looking for credit from Airbus for this particular fix, but because it brings the fuel burn benefit and it lowers the metal temperatures during climb, it's easy to do and it's easy for the customers to upgrade. We're going to spend the money, give our programmers and our controls engineers the funding and resources so they can develop that capability and put it into software.
And stay 1% ahead of the other guy.
And stay 1% of the 1% of the other guy. And that is something that's one of our goals.
Thank you very much.